In this video, we'll set up our very first web server for our first microservice. I decided to use Golang for the first microservice, as Go was designed for building scalable microservices in mind. I already have Go installed and my repository is ready. Let's go. Okay, so let's set up the assembly directory. This will house all the entry points for all the microservices. And we will probably refactor this at a later stage as we add more microservices, but I don't want to spend too much time on it now, as this will also evolve with time as we grow. Okay, now let's create the main file. Just gonna call it alchemy for now. And let's create the main function as well. And of course the package also needs to be set to main. Okay, so for the sanity check, let's do a printout of hello world just to see that everything compiles and is working as expected. And voila, we've got a printout. I will primarily use the command line interface to build and run my applications, so if you're not familiar with the command line interface, I would strongly urge you to just learn the basics. Okay, so let's navigate into the assembly directory. Let's run go build. And if we run the executable, we can see hello world. Next, let's talk about logging. We are going to use the logres structured logging for Golang. This will enhance our monitoring capabilities further down the line. Structured logging allows us to create a standardized format across all our microservices. This furthermore allows us to add contextual information such as timestamps, request IDs, service IDs, or any other metadata, and then seamlessly integrate into log monitoring tools such as an elk stack. Okay, so for now I'm just going to add a startup log. I'm just going to set the version to version 0.0.1, and then later on we will infer the version from an environment variable. Now let's add an endless loop to keep the server application running while we are waiting to serve incoming requests, and then also allow the application to be terminated from a kill signal. So let's add a buffer channel that will listen for interrupt signals from the OS. And then we register the interrupt channel. And then we create a for loop and a handle that will listen for any signals on the interrupt channel. And this is typically used for gracefully shutting down your application. Now if we run our application, it will stay alive until we manually kill the application, which we can do by pressing Ctrl+C. Lastly, for this video, we are going to set up a basic web server using Gin as a routing engine. Gin is a lightweight, high-performance web framework solution for developing microservices. Gin enables us to handle high traffic loads with ease. In the past, I've always opted for using the Gorilla multiplexer, but the Gorilla multiplexer has been archived at the end of 2022, and whether software is still being maintained should always be an important factor in your decision-making process on which tools to use. If software is not actively maintained, you will not receive any security updates, which can leave your applications vulnerable. You will also have limited support from the community, and the community will slowly fade away. Okay, let's jump into Gin. Let's create a router instance. This is all taken straight out of the Gin documentation, and I'll put a link in the description to their GitHub page. After we created our first router instance, we can set up our first route. This is a basic GET request to our server on the API path. And we now also define the response object for an incoming request to our specific route. We will set the HTTP response status code to 200 with the built-in status code constants, and we'll define an object that will make up the response body. We will expect to see a JSON object response with the message "Hello World" when we do a GET request to our server on the API path. Okay, so let's run our server now, and we can see in the logs that our route is registered on the router instance. And the last step required before we can test our route is to expose our router by starting an HTTP server. And this can be done using the router run function. Okay, great. Let's build and run our server again. We will use the built-in HTTP client to test our server. Here we have a request file of type HTTP, and we specify a GET request to our server, and of course the endpoint has to include the API path. And if we execute this HTTP request, we can see the response, which is the JSON object with the message "Hello World." This might not look like much, but this is the basic building block of our microservices application. In the next video, we will implement a gRPC adapter that will be the main protocol of communication with our microservices. Thanks for watching, and see you in the next video. Cheers!